This is Ed Robinson at Kensington College, talking today about C#, Chapter 6. We're going to be talking about arrays. In particular, we'll start off a one-dimensional array and consider other dimensional arrays later on. So we can make a one-dimensional array like this, where this is an array of integers. The square brackets denotes array. That's very important. Brackets, square brackets means array. We can have any array variable that we'd like. We've called this one age. Inside we have integers. Notice that the type is denoted here. I mean, if we wanted to put this as a double, then we could indeed do that. There would all be doubles inside, but they could only be one or the other. That's the thing about an array. They can only hold one type at a time, so that these are all integers. You could have all strings, but you can't mix and match like you do, and that's the purpose of a structure, really. A structure is something which contains different types at the same time. And we're using curly brackets here to initialize the elements in the array. If we want to print out one of the elements, then we would use notice that we start off with element 0. We're using square brackets, the name of the variable for the array, and we're using square brackets, but notice we start off with element 0. Now element 0 is the first element in the array. This takes a bit of getting used to because they're numbered from 0, 0, 1, 2, 3, 4. So this is element 4. There is no element 5. If you tried element 5, you'd get an error, a very drastic error. So don't do that. It's 0 based, so once you get used to it, it's okay. But if you start off with element 0 as the first element in the array. So if I want to print out element 0, if I can safely build that and I can safely run it, and then I will find that the first element is printed out, which indeed is element 1. So I'll stop that program. I could also show that we are indeed making a new object by using the new construct. We could even qualify that will run perfectly. You could try that if you want, or we could just emphasize that we've got 5 elements in the array and we can build and run that. This has been, I've heard this described as syntactic candy to add that as well. You'll find that it works perfectly well without it. But you will see it really more like this, referred to like this in standard textbooks. So let me just build this to make sure it's all still in order, and I will therefore just run it to a breakpoint here, which I'll insert here. I'd like to go and have a look at the array in memory. You needn't bother with this section for the moment. If you don't wish, you could fast forward, but it is interesting perhaps to look and see how the elements are stored in memory, and to emphasize that an array is a reference type. What do we mean by that? A reference type is when the actual address is stored in memory, and that address then refers to the actual array which is stored somewhere else in memory. So let me run this program down to the breakpoint, and I'll try to open a watch window for a start. All the windows are accessible through here. Windows, then we have the watch window, and then the memory windows, which are useful to look at. So in particular, I've got the watch window. You may just be able to see that where it says that it's ampersand age. Ampersand means the address of, and you type that into the watch window. We come up with this address which you can probably just see, which is 20DDF0, which is in hexadecimal. So in my first memory window, I will type that address. You might just see it there, 20DDF0, and then we find our array. Oops, oh no, no array. What's there? The address of the array. So what we need is another memory window. And in this memory window, I need to carefully type in this address. This address here, it's a little bit hard to see, but it's written backwards. It's 0246. So what I do is type in here 0, 2, 4, 6, which is this thing here backwards. And when I do that, I find my array. Oh, well, not quite. There it is there. Now notice how these are the 4 elements in the array stored sequentially in memory. This stuff is indeed to do with the array, but it's the header for the array. But that's a little bit confusing, but the point is this, that at the address AGE is not the array itself in the first memory window, that's the address of the array. So AGE holds the address of the address. So if we take this address and look at here, we put in this address here, which is this address. So this is indeed a reference to the actual array itself, which is here. Well, as I say, it's got a bit of a header, and these are the actual elements in the array. At the end of the day, this is how the array is stored in memory, byte by byte. Let me now just stop debugging, and I'll take the breakpoint off. I just want to emphasize how that this part of the array is declaring the array, and this part here is initializing the array. Indeed, we could put that on 2 separate lines. Emphasizing here that this is the actual declaration. Now when we declare the variable, we don't assign any of the memory that we just saw for the 4 elements. All we're doing is defining a variable which is going to act as a reference to our array, but there's no memory being assigned at the moment. Then we come to initialization, where the memory is assigned. Indeed, we could not initialize it to our values. If we were to run that, you would find that the values had been initialized to 0. In each case, you could try that for yourself. And finally, for one-dimensional arrays, you might like to try this exercise. We could make an array of integers just like we did previously. And what we want to do is to find the maximum value in the array, which will start off by saying we'll assign a variable equal to the first element, and then compare and swap if necessary. As you go through the array, you'll need a loop to go through that. So try that exercise. So we could start off by declaring and defining our array in the simplified way. And what we need to do is to set up a variable max, which will start off by putting that equal to the first element. So, for example, something like this. We then need a for loop, and we need to iterate through our array one at a time. Notice that we're starting in the second element, and we're going through to element 4, so it's less than 5. As we go through the 4 remaining elements, 1, 5, 9, and 3, we need to compare each one with the maximum value that we've got so far. And if it is bigger, the element that we find is bigger than that, then we need to set it equal to max, which we can do like this. We can say max equals that value. Then finally we want to write the value of max, so I'll do CW and then tab, and then we were looking for max value. So then I can build and run that, and indeed it finds the maximum value, which is 9. You might like to single step through that. That'd be quite instructive to find out when it does the actual swap. As a further exercise, you might like to try to sort the array. It's not as easy as it looks. We've already got one loop, but we need another loop inside our current loop. And the trick is to make the value of j for the inside loop start off at the current value of I as we go down. So you'll need to think about that. It's quite difficult, but the output should be that they should be in sorted order. So it should be 1, 3, 5, 7, 9 should be your output. We'll talk now about two-dimensional arrays. So this is a two-dimensional array. Notice the notation here, a little bit tricky to get used to. We have a comma there indicating 2 dimensions in the array. And note the curly braces that we use. We enclose curly braces within curly braces when we are initializing the array. We've given it the variable name age, and it can only hold integers. And if we were to print out one of the elements, then you notice that the notation here, you need to get used to that notation. 0, 0 will print out the very first element, so it's the 0th element. So this 0 denotes the first row of the array, and this 0 will denote the first element inside that row. So when we run that program, we should get printed out the very first element, which is the element 1. Once again, a 0-based array. As previously, we could embellish the definition. We could even include the dimensions here as well. 2 rows of 4 columns. You could build that and run that. That will work just as well. This part being the declaration, I could emphasize that by just breaking this up into a definition as well. So we're declaring our array here, and then we're defining it, initializing it. So you can run that, it'll just do exactly the same thing. If you didn't want to have them all initialized as zeros or initialized as you have here, then we could just define our array thus, and they would all be initialized as 0, which you could confirm by running the program once again. And indeed it prints out the first element as being 0. So when we use new, it initializes all of the elements to 0. You might like to look in memory and look at the watch, use the watch from the memory windows, and you'll find that your array is placed thus. This is the first row of elements, and this being the second row of elements. And of course all the elements are sequential, but the first row and the second row. Much like you have in mathematics, you have a matrix of 2 rows. We might like to print out the elements in an array using a for each. So if we have we'll revert to our original array, and if we'd like to print those out, we could use the for each notation, which is quite convenient. You might like to try that. So for each element in the age, and let me just run that, build and run, so I'll just run it. And the output is sequential, so it just prints them out one at a time. There's my first row there, and there's my second row. It doesn't distinguish, it just goes through each of them in memory, as you saw, sequentially, one at a time, using the for each. I previously mentioned that our array of elements is represented mathematically with as square brackets and the elements as we have here. We call this a 2 by 4 because it's got 2 rows and 4 columns. And a matrix which looks like this would be 2 rows and 2 columns. We call this a 2 by 2 matrix. So finally we could try this exercise, adding together matrices. Matrices, you may know from mathematics, is you add the individual elements in the box. 1 plus 1 gives you 2. Then, for example, 2 plus 3 gives you 5, and so on. So you're adding the corresponding elements. You can start off by declaring and defining your first array, which we'll call M1, first matrix. Matrix is the two-dimensional arrays are matrices. A matrix can be many dimensions, but in this case we have a two-dimensional matrix and a two-dimensional array. We start off by declaring and defining our array M1, and you can do the same with M2, and then you can simply add the elements together. As another exercise, you might like to try and add them together using a loop inside a loop.